This is the video for lesson 129, page 532. And this lesson is all about measures of central tendency. This is a lesson from statistics. And there are different measures of central tendency that work better based on really how your data is distributed. All right, so the first thing we're going to talk about is a stem and a leaf plot. It is a way to represent your data and really to see the spread of your data. So the stem represents the highest digit in whatever your data is. It could be, if your data has a single units digit with a decimal, your stem would be your 3, your leaf would be, your stem would be your 1, your leaf would be your 3. If you had hundreds, okay, your stem would be probably both of those digits, the 1 and the 3, the 13 would be your stem. Your leaf is going to be that single last digit. Okay. All right. So when we're looking at stem and leaf plots, we write our stem to the left and our leaf to the right, and there's a line that divides them. So looking at these values that I have here, all right, in all of these first 6 digits, the stem is 1. So I write the stem 1 time. Then I write the units digit as my leaf. So just evenly spaced. I do repeat if it is repeated. All right, and then for my 20s, I have 1. Notice how they line up. 5, 5, that's all I have. And for my 30s, I have 3 30s. Then I have a 1, a 2, and a 9. All right, and that is really all a stem and leaf plot. It helps us to see how this data is distributed. Now, actually, if you turn your stem and leaf plot over on its side with the stem on the bottom, you can see how it would be distributed. So this data is pretty evenly distributed. The example in your book is not evenly distributed if you turn it on its side down here. It's almost a normal curve. So just thinking of a curve, that would be your distribution. Okay? All right. So a stem can help us really define measures of central tendency. All right, the other measures, so where's the center? And this is like evenly distributed, so the center would be really close to the middle. All right? Now, you've heard these before: mean, median, mode, and range. These are all statistics values. The mean is either mathematically looks like that, like a mu almost, or an X with a line over it. What is the mean? The mean is the sum of all the values divided by the number of values that you have. Okay, the sum of all of them divided by how many values you have. So the mean is a good measure of central tendency when all of your values are pretty close together, like the ones I have on the board. They were all in the 10s, 20s, and 30s. The mean is not a good measure of central tendency or where your center lies. If, for example, I have like 10, these numbers, 11, 20, 25. Then I have this huge number out here, 1,000. This is called an outlier. It is so far from where your other values are, that it skews the distribution. It really skews it left because you have this huge number on the right. And so your mean, like if this were the average price of a thermometer, right? Where at COVID, thermometers are crazy nowadays. This number would make my average so high, it skews it towards the 1,000. So the mean would not be a good measure of central tendency, right? So you would add these 5 numbers and divide by 5 to get the mean, all right? The median. The median is the middle number. So the median would be a better measure for central tendency than the mean for this set of numbers. So when you have an outlier, it would be more accurate to look at the median to see where your center is as opposed to the mean. All right, so it's just the very middle number. If there's an odd number of values, it's the very middle number, so it would be 20. If there's an even, so let's add a number down here. If there's an even number, you take the middle 2 and it's the average. So it would be 11 plus 20 divided by 2, okay? That's the median. It's the middle number. It's a great measure of central tendency when you have an outlier, all right? Now, the mode. The mode is the number you see the most. Okay, you can have no mode. A set of values can have no mode. Like, all right, let's do no mode. No mode would be like, no numbers are repeated, right? There's no mode here. There can be a single mode. This is a single mode. So 8 would be the mode. There can be more than one mode. So 8 and 12 would be your mode. Okay? So we're going to look at how these 3 are related when your data is evenly distributed about the mean. Okay? Because these 3 values will all be the same when we have a normal distribution. All right, the range of your data, it's not really a measure of central tendency. The range is the highest value minus the lowest value. So it helps us to know what the range of the data is. It's just the high minus the low. So we use the range and the median to graph a box and whiskers plot. Remember that? You had a box and whiskers plot where this was your low number, this was your high number, the middle is your median. All right, we're going to do all that next year in pre-calculus, all right? So you have these 3 values, mean, median, mode, and then you have range, okay? The mean, median, mode are really measures of central tendency. All right, so let's work a problem. Let's suppose that on the Algebra 2 midterm exam, here were the scores. Here were one of my students' scores in the first semester. All right, all of his grades, first semester. All right, let's say he made an 80, he made an 81, he made a 92. Well, then he bombed one, but then he really did well. So he had 5 tests that first semester, okay? And I asked the question, what if I asked the question, what would he have to make on the next test, so on test 6, so that his average Maybe he wanted to have an A in the class, a 90. All right? Let's make sure, see if he has a 90 right now. So, to get a 90 in the class, at the very least, he has to make an 80 plus an 81 plus 92 plus 70 plus 98 plus whatever he makes on that 6th test. When you take the average of it, you want it to be 90. Okay? This is how I see this problem presented on the ACT typically. All right? All right, so follow along. You've got to figure out what he needs to make on the next test. I'm going to use algebra. I'm going to eliminate the denominator by multiplying every term by 6. On the left-hand side, that eliminates. 6 times 90 is 540. 540. I'm going to add all of those values and just leave them as one. So it's 80 plus 81 plus 92 plus 70 plus 98. So it's 421 plus whatever he makes on test 6. Gonna have to be some bonus on there, huh? All right, so then you subtract the 421 on both sides, and that's what he has to make on test 6. So he's praying there's some bonus opportunities, right? 119 on test number 6. All right, so I want to go and look at example 129.1 in your book on page 533. All right, if we're looking at that problem, it wants us to find the mean, median, mode, and range of those values. The first thing you do is you write those numbers in order, smallest to largest. All right, so we have a 3, a 4, a 7, an 8, a 9, another 9, a 10, and a 12. 2, 4, 6, 8. Do I have 8 numbers? 2, 4, 6, 8. Yes. Okay, I already know the mode is 9. For the mean, I'm going to add them all. 3 plus 4 plus 7 plus 8 plus 9 plus 9 plus 10 plus 12, and divide them by 8 to get the mean. So 3 plus 4 plus 7 plus 8 plus 9 plus 9 plus 10 plus 12. That's 62 divided by 8. And it should be somewhere close in here because I don't have an outlier, right? And it's 7.75. 7.75. Okay, that's the mean. All right, the mode was 9. All right, let's see what the median is. The median is the middle number. All right, so I'm going to count in. There's 8 of them. It's going to be the sum of 4 and 5 divided by 2. All right, so it's going to be 8.5. So when your median, when you have an even number of values, you take the 2 in the middle and divide by 2. The range, all right, so look how close and tight these values are. These values are pretty close, and I was expecting it because the numbers are pretty close together. All right, the range would be 12 minus 3, which is 9. All right, so that's the mean, median, and mode and range. Okay, now, standard deviation. All right, when we have a normal curve is a bell-shaped curve. Okay, that's not perfect, but it's a bell-shaped curve such that this highest point of the curve, it's called the maximum. The highest point of the curve is actually where my mean is. All right? Such that 50% of the values lie to the left of the curve and 50% of the values lie to the right of the curve. All right, if I were to figure out how many are to the left and the right. Because here, when it's a normal distribution, my mean is always going to equal the median, the middle number. So that's why 50% lie to the left, 50% lie to the right. Okay, so what is a standard deviation? The standard deviation really just describes how the data is distributed from this center out, okay, such that we can know something empirically, okay? All right, so what is true when we have a normal distribution of the data and your mean equals your median? Then we can know that one standard deviation to the left and to the right, that's one standard deviation to the left and to the right, within one standard deviation of the mean, 68% of the data lies within one standard deviation. So I'm going to write that. So 68% of the data, Paula, lies within one standard deviation of the mean. All right, so standard deviation, we're going to use that symbol, okay? All right, so one standard, and we're going to give some numbers in just a minute, okay? All right. Now, within two standard deviations of the mean, so from here, all of this area under that curve, all of the data under that curve, we know that 95% of the data lies within two standard deviations of the mean. So this is the empirical rule, which you will have to memorize. 68% within one standard deviation, 95% within two standard deviations of the mean. And then finally, 99.7% of the data lies within three standard deviations of the mean. So let's look at this with real numbers, okay? If I have a normal curve, all right, and I say that the mean, we're just going to put the mean at some nice even numbers. If I say that the mean is 50, okay, and I say, so the mean is 50 and a standard deviation is 5. So the standard deviation is 5, okay? We're going to calculate standard deviation in just a minute. All right, so one standard deviation from the mean, I add 5, I subtract 5, so that would be 45 to 55. So what that would tell me is, if this is a normal distribution, then 68% of the values in whatever I'm looking at and researching, 68% of the values lie between 45 and 55. Those values. All right, if I go one more standard deviation, I'm again subtracting 5, I'm adding 5. So this is 40 to 60 is two standard deviations from the mean. And what would that tell me? 95% of the data, of the results, would lie between 40 and 60. And then I could go to 35, one more standard deviation away, to 65. And I could know with certainty that 99.7% of the data lies between 35 and 65. All right, so here's some other things I could know. 50% of the data is less to the left of 50, less than 50. Also, 50% of the data is greater than 50. All right? Now, where's this 0.3? Because all probabilities should be equal to 100 percent. Here's the 0.3. Half of it's here and half of it's there. So 0.15% lies here, 0.15% lies there. All right? So what is the formula for standard deviation? The first thing you have to calculate for standard deviation, the first thing you have to calculate is the mean of the data, all right? So, looking at the values 5, 7, 10, and 14. If we just have the values 5, 7, 10, and 14, and we calculate the mean of those. So I'm going to divide that by 4. All right, when I calculate the mean, that's 5 plus 7 plus 10 plus 14 divided by 4, so it's 9. The way you calculate the standard deviation is you take the square root and you take every value minus the mean and square it in the numerator. I'm taking every value minus the mean and I'm squaring it. So this will be long. So 5 minus 9 squared. And I'm going to add them all together. My denominator is going to be 4. How many values I have? All right, so I'm taking the difference, how far each of these terms is away from the mean, and I'm squaring it, okay? All right, so then we're going to take 7 minus 9, and I'll square it. Then we'll take 10 minus 9 and square it. And then we have 14 minus 9 and square it. All right, so the standard deviation is, that's negative 4 squared, which is 16. And this is all going to be over 4. That is negative 2 squared, but that will be 4 when I add it. That's 1 squared, that's 1. That's 5 squared, that's 25. So adding this under the square root, I get 16 plus 4 plus 1 plus 25. This is 46. So I take 46 divided by 4, which is 11.5. Then I take the square root of 11.5, and my standard deviation is 3.39. So if I were drawing the normal distribution curve, all right, my mean would be 9. 1 standard deviation, I would take 9 plus the 3.39. So this would be 12.39. That's 1 standard deviation. 2 standard deviations, I keep adding 3.39 to that. And that's 15.78. And 3 standard deviations above it, I just keep adding the 3.39. So that's 19.17. Going down below the mean, I take 9 and I subtract that standard deviation. So this would be 5.61. 2 standard deviations, I again subtract 3.39 and I get 2.22. 3 standard deviations, I subtract 3.39 and I get negative 1.17. All right, what can I know from this normal curve? I can know that 68% lies within 1 standard deviation from the mean. That's between 5.61 and 12.39. 2 standard deviations, that's this area. This area right here is 95% of the data. And between 3 standard deviations, that's 99.7% of the data. I can know 50% of the data is to the left of 9 and 50% of the data is to the right of 9. All right, so how do you calculate standard deviation? First, you find the mean. And then you take the square root of each of these values minus the mean, and you square that and divide it by how many values you have. And then you take the square root of it. Okay, that's it for lesson 129.